With this, I think I would like to hand over to Santanu to share his experience and the presentation on the outage incident of fully virtualized mobile network and its learning from it. Santanu, over to you.
Thank you, Rupesh. And before I start, just a quick time check. So, is it like 25 minutes what I have, or can you advise?
Yes, yes.
All right. Thank you.
20,
Thank
20
you.
to 25 minutes is fine.
Thank you. So, good morning to everyone, and Happy New Year to all of you once again. So, those who doesn't know me, so my name is Shantanu Dasgupta. I work at Cisco Systems as a part of my day job, based out of San Francisco Bay Area. And as Rupesh have said, that I have a very fond, very deep, and very close to my heart association with SANOG since 2006. And it was around 2017 when I relocated to US. I lost touch, totally my fault. And I was missing it so much that I thought that, hey, this is enough. I have to get back, getting together with all of you guys once again, so that I can learn from each one of you and share and exchange ideas and do my little bit along with all of you with what we have been doing so far. So it has been it is a great pleasure and honor for both for me at the moment to be back with you guys, and I can't really wait to get back for the next physical meeting. Hopefully the next one in 2021, the middle of it, we will be back again together. So around 2013, which used to be called or still called Network Functions Virtualization, or NFV. Uh, and that was dealing with how we can virtualize different network functions and bring the aspect of cloud into networking. And I was thinking, when the program committee asked me this time that that I do a keynote, I was thinking, should I talk about the journey of NFV for last 7 years? But I then thought it might be a bit boring, and it may be rather uh, a bit more worthwhile to talk about something which is a little bit more specific, a bit fun, and has the operational angle attached to it, given the fact that all of you day to day are operating some network or other in your respective countries and in your respective companies. So I'll try to do my best to outline a major outage incident in a fully virtualized mobile network. And this is where the notion of telco cloud or NFV actually still comes in. And more importantly, we'll see some of the key learnings that we derived out of it. Okay. So quickly about the operator, just for the sake of privacy, I have thought that it may not be worthwhile to call their name explicitly, but they are one of the mobile operator in your backyard, somewhere in the Asia Pacific region, and they also happen to be one of the operator, maybe the only one at the moment, or maybe among the very few aspiring ones who have deployed a fully virtualized and end-to-end automated network, which is running in production right now. None of this are myth. This is actually deployed in production, serving real customer traffic. Now, when it comes to the context of virtualization, so far we have seen it happened mostly in the area of core, like voice core, data core, and all the IT services of the telcos. However, these guys, given they did not really had a lot of legacy and they were deploying a new network, they decided we will take this concept all the way to the access as well. In this case, the radio access or virtualized radio access network, vRAN. And we'll deploy mobile edge computing, which is sort of the buzzword right now, where the operators are looking at incremental way to monetize by bringing in new services, leveraging the notion of low latency. Now, this is a network architecture that has multiple tiers of telco data center, starting from core to the region to the far edge, thousands of them actually. And it sort of creates the foundation of a distributed telco cloud, which is end-to-end orchestrated for automated provisioning and automated lifecycle management. And of course, last but not the least, this is, of course, being a new network, fully end-to-end IPv6 based. There is almost no IPv4 in this network, except certain areas where IPv4 is actually mandatory for certain applications because of the lack of application support. Now, the incident itself, now, fortunately, the incident actually was of very big magnitude, but the blessings in the disguise was the incident itself happened during the user trial phase, or in other words, the network did not really entered into a full commercial launch phase. So it's in that sense it was sort of a lifesaver, given the fact that when you see the incident, you'll see the magnitude and the impact of it. And if that sort of thing happens in a real production network, a lot of people will be in real trouble. And the other silver lining was the size of the network was also not that big. There was around less than 1,000 cell sites, which was operational at that time. Things have grown since then. They have like more than a few thousands now, and very soon there'll be few tens of thousands, in another 6 to 12 months time. Now, the incident itself was catastrophic in a sense, like every 2 to 4 days, very unpredictable in the sense of like when it happens from a time of day perspective. Sometimes it happens in 9 o'clock in the morning, sometimes it happens in the midnight, sometime in like evening. So it's completely unpredictable. And the day of the week was also unpredictable. But within 15 minutes of the time, like time equal to 0 to 15 minutes, almost half of the network, half of the cell sites at that time would go blank, complete blackout. Now, you can imagine in your head that an outage like this is fairly nasty in a sense. Like if you think in your respective country or city and think of any mobile operator who are in business, think of you guys in Nepal as a host country, and just imagine half of the Kathmandu city is completely blacked out. There is no mobile coverage. So you can think of that would be sort of a disaster for that operator. Okay. And that was similar situation here. Only safety net, as I've said before, that it was not really running any commercial traffic that the customer was billing to its end user. So that was the only safety net. But of course, there were tens of thousands of friendly users who were actually testing, trialing the network, and it was pretty severe and became a save one escalation almost in no time. Now, my role in this project was, from Cisco's point of view, Cisco had played a big role in this project from multiple aspects, multiple parts of the solutions. And I was the chief architect from Cisco side designing this network. And also, this operator, when they started their journey, they were very small, like less than 10 people. They did not really had a lot of experienced senior architects or engineers who can design and deploy things. That's not the case anymore, but I'm talking of like 3 years back when this all started. And and along with me, a few other guys were also playing the role of one of the operator architect team. Okay, so, and we were actually sort of like helping them design the whole thing and helping them deploy the whole thing. So when things go wrong, obviously they will reach out to us because they know we designed it, so we know inside out what's going on or might be going on, and we can help. And that was the case, where a few of us were asked that we make this priority one and jump onto it right now to figure out what went wrong and how we can fix this. Now, before we dive into a little bit more detail of the problem and the root cause of the problem, how we found it and what was causing the issue, a little bit of a basics of the radio access network itself. And again, the objective here is not to get into any details or foundational concepts of radio access. That's a very complex topic, might be a little bit orthogonal as well in this community. But you will understand the basic concepts here, that just like the OSI model that we all learn in networking, where we have 7 layers, in radio access stack also there are multiple layers. And the lower 3, RF, low-fi, and hi-fi belongs to layer 1, MAC RLC to layer 2, and the upper 2 belongs to layer 3. What's important to note here is the traditional deployment model actually puts all of these layers into a single physical appliance that we deploy at the cell site that we call in 4G LTE environment eNode V, or the legacy 2G environment, we call this a BTS. However, there is a new evolving model which is being discussed. It's not very widely deployed. It's deployed in a few locations at various degree of scale, but this is being very widely discussed at multiple forums in the industry for a while for multiple reasons. And again, the focus is not to discuss on those reasons, but the way the evolving model differs from the traditional model is the evolved or the evolving model actually promotes the concept of disaggregation and virtualization. And it says that, hey, instead of packing all these layers into a single physical appliance, we can decompose them and create different units, such as the top two layers can be used to create a centralized unit. The middle three layers can be used to create a distributed unit. And the lower two layers can be used to create a radio unit so that we can virtualize some of it, keep some of it as physical, but more importantly, we can deploy them at different places in the network. Some might go in the cell site, some might go in the pre-aggregation, which in our part of the world in South Asia, we call more the exchanges. In the US or the other part, we call this central office. And some part like the upper centralized unit can even go in a regional location, like maybe few tens in the country of a size like Nepal, if you think in your head. So the reason I'm showing this evolving deployment model, because this was exactly used in this network. Even you recall, I said that this was fully virtualized with virtualized RAM. And the way it looks like that all these components, the RU, which is a radio unit, distributed unit, and the centralized unit, are interconnected with a data plane network, of course. They have to pass user traffic, right to left and left to right, all based on IPv6 once again. But they also have their respective management interfaces, call it out-of-band management or what have you, through which it's communicating to its respective management system, but also a lot of ancillary capabilities, which are sort of a lifeline for making such systems in virtualized environment work at scale. If I'm deploying a virtual centralized unit or a virtual distributed unit, I can't really deal with like static IP address allocation. It has to be always dynamic with DHCP, or the one system talking to the another system. It's always better to use fully qualified domain names for which I need to have a DNS system so that it all becomes very automation friendly. And of course, each one of the respective management plane interface also have their respective IPv6 addresses, because IPv6, of course, is being used to make the management plane to interact with each other. And the DU and CU, both virtualized in place, are running on top of a telco cloud platform, which has its own respective orchestration, automation, and the operation support system. Now, one thing which you look at here is overall from a systems architecture perspective, a disaggregated system and a virtualized system from a system architecture point of view, once again, typically is more complex. I think that's a unfortunate reality. We just have to be comfortable with it with respect to how you build your knowledge and how you build your tool chains or workflow or your operations processes. Now, from a resiliency point of view, all the systems have been deployed, of course, with all the central and all the core services to be fully resilient. At least that was the goal, that was the intention, that was the design. I have a primary core, I have a backup core in a separate, completely physically separate location. Same for the DNS DHCP, right? Same for the orchestration system as well, so that even if I lose one of the data center, let's say the telco DC1, where all these services are present, the DC2 can provide all these capabilities. And from a systems point of view, we don't really create an outage. Now, keeping this in mind, and again, now it's the time to go to the meat of the session, which is how we troubleshooted and how we identified the root cause and how did the root cause actually look like. And again, the issue itself was every alternate 2-3 days, half of the network is going blank. Okay, and we're like trying to find out what's causing this problem. Now, unfortunately, at that point of time when we were dealing with this issue, and we were like almost 24/7 trying to solve this, and unfortunately, we did not really had a proper tool chain and instrumentation capabilities. Okay, the situation is obviously much better now, but that was not the case at that point of time. And as a result of that, Given with a lack of tool chain and lack of instrumentation, you will be dependent on a lot of manual processes or manual investigation. So we sort of try to identify, at least to the best of our abilities, almost all possible elements that can cause failures, and we started checking on each one of them one by one. Okay. However, once we did all the primary checks, we found absolutely no major red flags on the initial check, and also after the log scrubbing of everything that we could have actually gathered from the network. Routing was good, connectivity was good, there was no issues as such anywhere there. Mobile core was functioning perfectly okay, ran software has no problem, telco cloud platform, orchestration system, everything seemed fine. Now, with all seemed okay, we still can't figure out what's causing this issue. And we lack the tool chain, we lack the instrumentation. Unfortunately, we had no choice apart from waiting for the next outage to happen. And our goal was, hey, we are now jumping after the outage, and trying to find out what might have happened then. And we still can't figure out anything. And we have no other option apart from waiting for the next one to happen. We'll catch it live and we'll check if we can find something more, at that time. And given, if you recall, this was unpredictable, so we sort of like agreed that we'll be on a sort of a hotline arrangement, and moment it starts again, we'll be on a call in 5 minutes, irrespective of wherever we are. Okay. And that happened. Fortunately, the way we anticipated that, or planned for that, during the next outage, we were able to jump on immediately on the system, and we collected more logs from all potential elements. And once we did that, upon very comprehensive scrubbing that was done, we found some DNS timeouts happening, okay, on the radio unit. Now, why DNS timeouts, or why even DNS? As I was saying before, that all elements, including the radio unit, uses the fully qualified domain name of the respective distributed unit and central unit. Think of like you're taking a router, you have decomposed the control plane and the data plane, quote unquote classic SDN context. And the data plane is trying to talk to the control plane, and that communication in the management interface is using a fully qualified domain name. So that's a very equivalent analogical example to the radio system that I'm trying to explain here. And of course, if I'm trying to resolve the FQDN, I have to make DNS queries, and we saw timeouts, and it seemed like this could be the problem. And just to make sure that we are checking it right, we picked some random radio units that was in the failed lots in that outage, and we put static entries of the respective distributed unit and central unit in the etc host file to avoid future DNS queries. And actually found to be the cause, because in the subsequent outages, all those RUs where we put static entries remained up. And that was our goal. We wanted to put static entries and see if they remain up or they go down. If they remain up, then it's actually the DNS which was causing the issue. So now we were sort of like narrowing the problem space, and we found that DNS is the issue. And then the next step was to figure out what exactly is going on with DNS. Okay, well, what's wrong with DNS? Why this is failing? Now, in order to understand that, this is again a super high-level illustration of how the DNS system was architected there, or supposed to be deployed there. Once again, every single element, the RU, the DU, and CU have their management interface through which they can talk to the DNS. And the DNS are deployed in two data centers, data center 1 and data center 2. And they have a cache DNS, and they also have an authoritative DNS. Again, standard stuff, no rocket science here. And between the RU and the DU, every 10 seconds, that uses the FQDN of the DU at the RU side, and vice versa. The DU also uses the FQDN of the RU to do the heartbeat. Now think of this guy has just booted up, and he's trying to send a heartbeat to his DU peer with an FQDN. He doesn't know what is the IP address. So he sends a DNS query that goes and hits the cache DNS. Cache DNS also doesn't know it. So he queries the authoritative DNS, gets a reply, and the reply is then cached at the cache DNS for 60 minutes. And the response actually comes back to the radio unit where it is further cached for 1 minute. Now I have the IP address, I can talk to this guy over the management interface. And I'll do that for up to a minute. And after a minute, the cache entry would be flushed. And I will hit again the cache DNS, and the cache DNS should be able to respond from the local cache itself right now because it's caching that entry. And after 60 minutes, of course, the standard DNS technique, no rocket science here once again. Now, what was going wrong was two things. One, we had a bug that the cache DNS was intermittently stopping responding to the DNS queries. And we also figured out that given this network was being built at that point of time, and when some of the initial cell sites were deployed, not both the data centers were active, only one of the data center was active. So those cell sites were commissioned using the name server of only the primary DNS. And when the backup data center came up with the backup DNS system, these cell sites were not really updated from a configuration management perspective to add the backup name server IP address. Okay, that was supposed to be the case, but did not really happen. Again, it was probably the fault of the process. It was not a fault of any individual. Everybody was working under tremendous pressure, so it was a fault of the process through which we could not really had that configuration check, or the call it a configuration audit against a golden parameter that could have ensured that all the sanities are in place. However, all the new sites that came later, they were configured with both the primary and the backup name server. Okay. Now, think of a scenario where this cache DNS is hitting the bug and not responding to the queries. And these guys, their local cache is running out after 1 minute. And after 1 minute, they are not able to get any response back from the DNS system. They are not configured with the backup DNS anyway, so can't even reach out to the standby DNS. And they are just going finicky and they're rebooting themselves. And after reboot, it's even bigger chaos because they can't even get some of the basic infrastructure IP addresses because some of the other systems at the back end, which is probably impacted because of all this. So that was the root cause. And again, I mean, looking at all of this, if you see from the overall experience point of view, I think we took 5 major takeaways, and I'll share each one of them one by one with you. Rather, there are 4 here that we took, and the 5th one is I added for you guys as the audience. The first one is the strong knowledge of networking and fundamentals are still very, very foundational. Now, we are talking of a lot of new things in the context of cloud, virtualization, programmability, automation, orchestration, what have you, data modeling, like telemetry, like all these sort of new things. But the foundational knowledge of networking and the design fundamentals, basic philosophies, they are so very important. And it's very important that we solidify all of that and build on top of it. Second, I think this is a no-brainer, and we know this, but I think we need to tell every day to all of, like each one of us, that we need to think about operations in every single stage when we do design and when we do deployment. Every single thing that we deploy, we need to ask ourselves, if I'm sitting in the NOC, how the heck I'll automate this? Do I have the right tool chains? Do I have the right processes, the right systems to actually do that with the right level of efficiency and response time from a feasibility point of view? And that brings us to the point number 3, that to solve the right problem and in the right environment, I need to have our target set of tool chain and instrumentation capabilities. Unless we have that, we'll not be able to hit an efficient operations as an outcome. And this was exactly the case that we were facing here. And had we had a system that would have told us that, hey, there are DNS queries which are failing left and right, looking at a dashboard, the whole process would have been much more efficient and much more simpler, and could have been done by even a level 2 engineer, maybe in the NOC. 4th one, the decomposed architectures, they tend to be more complex. This is an unfortunate reality. Once again, we just have to acknowledge it, and we have to be prepared to deal with it with the right knowledge and the right processes and again tools and everything. Finally, I said this multiple times during my 2014-15 timeframe, and I'll say that once again, that pay close attention to cloud and virtualization in networking. It's happening big time, and it is one of the key future mainstream. I'll stop here. I might have gone a couple of minutes over my time, but thank you very much for this opportunity. I hope this was useful in some way or the other.
Thank you, Santanu, for an excellent presentation. So, with this, I open the floor. If anybody has any question for Santanu or Vinay, we can type in your question in the Q&A section. Uh, Thank you, Santanu, for excellent experience sharing and excellent presentation. That's what I mean. Basically, we need to do. I mean, the operations, basic operations facts. So the basic network operations fact. I mean, the foundation needs to be built, and an understanding needs to be there. So excellent presentation to start the SANOG, I believe, from both the speakers, Binay as well as Santanu. I'll just wait for a few seconds to see if there is any question, and then otherwise we'll close this session for our next session. We'll have a short break after this session. Maybe I think it was 10 minutes or 15 minutes session break. 15 minutes session break. I think since we ran out a little bit longer for 5 minutes, so we'll just have a 10 minutes of break. I don't see any question, so I believe everybody understood it nicely, and then I think it was very informative. Santanu, thank you very much once again. Thanks to Binay as well. So we'll take a break for 10 minutes, and we'll come back to join our next technical session, where Simon will be chairing the session. We have excellent presentations on RPKI Invalid from Awal, followed by Let's Encrypt Automation thing from Philip Pipe, and then DNS presentation from Champika. So looking forward to those excellent presentations again. And with this, I would like to thank everyone for attending this first session. I Let me check one more time if no. So I do not have any questions from the floor. So with this, I would again thank Binay and Santanu, and we'll just take a break for 10 minutes. And Simon, over to you for next technical session, where there are I think three presenters doing the technical presentations. So we'll just pause for 10 minutes. Thank you, everyone, once again. And thanks, Niranjan, for resetting the timer. I think we have 9 minutes left now. Uh,
Deepak, can you bring all my speakers to the lobby? They are in the attendance mode.
Oh yeah.
Rupeshda, can we start?
Sure, Simon. So,
Yeah.
over to you for the technical session. Before I hand over, just a quick and as I mentioned again, our supporters for this event are Epinik, Apricot, NREN, Nepal Research and Education Network, NPNOG, and it's hosted by NPIX, and also sponsored by AWS, Amazon Web Services. Thank you. So over to you, Simon.
Rupeshda, thank you. Hello, everyone. Welcome to the Technical Plenary Session 1. This is we named as a operational security session. So we have a very elite panel with me right now. Introducing myself, my name is Simon Soel Baroi. I'm from Bangladesh. And today we have three distinguished speakers, Abdul Awal, Philip Peps, and Champika. Three of them are really known face to SANOG community as well as around the Asia Pac. So my first speaker is Abdul Awal. He's from Bangladesh, and he is also very keen to work with RPKI. In whole Asia Pac, we know he's one of the RPKI warrior. I found so many emails from Awal and uh, so many Facebook messages from different vendors, different operators to do the RPK stuffs. So I would like to welcome Abdul Awal and bring his presentation. Awal, the floor is yours. Awal, we can't hear you.
Yeah, Awal, we can hear you clear and
Rupesh Dai, we are having the same issue again. Can you look and check back, please?
না
certificates for all your services for free. So historically, getting a certificate is a slightly involved process. You generate your certificates usually by typing some OpenSSL command line, or you click some buttons in IIS, or depending on your software, you might have to jump through some other hoops. But eventually, what you get out of this system is a so-called certificate signing request, which is an X509 file, ASN1 encoded. It's standard format, very easy. You send this certificate signing request to a certificate authority and ask them to sign this certificate for you. And you repeat this process annually. And the step 3 is the one that's always a little contentious. Usually the certification authority, in order to sign your certificate, they will want from you some money. If it's a good certification authority, they will also want some assurance from you that you are you. And this can take different forms. The most common baseline certification authority will want you to prove that you have control over the domain name that you're asking a certificate for. Slightly more thorough certification authorities will ask you to prove that you're actually the organization you say you are. But the bottom line is that you give them money and they sign some integers for you and they give you some integers back. This is clearly a fundamentally flawed system. The certification authorities are answerable first to their shareholders. Their primary motivation is money, and improving security on the internet or individual networks or systems is only a secondary concern to them. But more importantly for this presentation, at least, I could go into the moral problems with certification authorities for hours. That's not helpful. But to the technical community, a bigger problem is that anything that happens annually might as well happen manually, because you're not going to automate something that you have to do only once a year. You'll just put a note in your calendar and do it manually. And this is error prone and easy to forget. So in the course of a year, system builds up entropy. You might forget your calendar, you change calendars, you don't remember the notes. So it's the worst of all worlds. You have to do it manually. It's error prone, it's easy to forget, and at the end of the day your system ends up with a certificate that is no longer valid. It's there's nothing wrong with the certificate per se, but it's not valid anymore because the signature has run out. So enter let'sencrypt.org. It's been around for a while. How the whole thing works.